Numbers is a very important topic because without this topic you can't do any other aptitude topic. So let's get started with the topic. Before getting into the problems in numbers, we need to check whether we do know the real definition of all the numbers. What are the different types of numbers that you know? Odd numbers, even numbers, prime numbers, composite numbers, rational numbers, irrational numbers, decimals, integers. At first, what is the definition for the odd number and even number? Simply, we can say that any number which is divisible by 2 is the even number, any number which is not divisible by 2 is the odd number. So, of course, 2, 4, 6, 8, all these will come under the even numbers category. 1, 3, 5, 7, all these will come under the odd numbers category. But what about the number 0? The number 0, does it come under the odd number category or the even number category? This is where the real definition of odd number and even number helps. The actual definition of the even number is any number when divisible by 2 should give a remainder of 0. Only then the number belongs to the even number category. Now, if you divide 1 by 2, the remainder is 1. So it belongs to the odd category. When you divide the number 4 by 2, you get a remainder 0. So it belongs to the even number category. So whenever your numerator is lower than your denominator, this number becomes your remainder. In the same manner, when you divide 0 by 2, 0 being less than 2 makes 0 as the remainder. So 0 belongs to the even number. Now the definition for prime number and composite number. Before the definition, let me just write down the first 5 prime numbers and first 5 composite numbers. 2, 3, 5, 7, 11. And the first 5 composite numbers are 4, 6, 8, 9 and 12. So 10 is also included. Yes. If you look at the definition, if you search for the definition of a prime number in Google, you might probably end up having a definition like any number which is divisible by 1 and itself is a prime number. For example, 2 is divisible by 1 and 2. 3 is divisible by 1 and 3, 5 is divisible by 1 and 5. Apart from all these numbers are your composite numbers. But this is not the real exact definition of prime numbers and composite numbers. The real definition is nothing but the numbers which are having exactly 2 factors. One factor will be 1 and the other factor will be the number itself. Yes, this is the real definition of the prime number. If you do check with this definition, all these numbers will come under this category. 2 has factors 1 and 2, 3 has factors 1 and 3, 5 has factors 1 and 5, 7 has factors 1 and 7, and 11 has factors 1 and 11. Apart from all these numbers are your composite numbers. Yes, let's try to check whether these numbers are not coming under this particular definition. Factors of 4 are 1, 2, 4, which is more than 2. Factors of 9 are 1, 3, 9, which is again more than 2. Factors of 12 are 1, 2, 3, 6, 12 and 4, which is again more than 2. So this is the definition that you can use it for finding whether a number is a prime number or a composite number. I believe that now you know the definition of prime numbers and composite numbers. So let me give you a question. Is number 1 a prime number or a composite number? Try to find the answer and put it in the comment box below. Now, getting into the classification of numbers, the numbers can be classified firstly into real numbers and imaginary numbers, and the real numbers can further be classified as rational numbers and irrational numbers. And the rational numbers can further be classified into decimals and integers. Decimals are nothing but incomplete form of numbers. So just the opposite of this is nothing but your complete numbers, like 8, 6, 14, minus 13, minus 44, minus 32. These are your integers. These are your decimals. I believe that this visual representation might give you a better understanding of decimals and integers. So in a number line format, any number which is existing between minus infinity to plus infinity in a complete format is your integer, and any incomplete number that is existing between minus infinity to plus infinity are your decimals. For example, minus 44 comes under integer category. Minus 83.4 comes under your decimal category. 3 comes under the integer category. 6.22 comes under your decimal category. We have missed out some important numbers, whole numbers and natural numbers. So in the number line, let's take the number line right from 0 to infinity. So all the numbers that are existing from 0 to infinity are your whole numbers, while the number from 1 to infinity are your natural numbers. The most confusing question that you can expect in numbers is finding a number to be a rational number or an irrational number. So to make it easy, I've taken 4 different examples, 4 decimal values, and now we are going to identify which of all these numbers belong to the rational category and which of these numbers belong to the irrational category. Let me start with the first example where the decimal is 8.325 bar. The bar actually represents the repetition of these numbers 3 to 5 until infinity, which means it's like 8.325, 325, 325, 325, it goes until infinity. Now look at this number and tell me what would be the 30th digit after the decimal point. Third digit is 5, 6th digit is 5, 9th digit is 5, and 30 is the third multiple. So obviously 30th digit after the decimal point would be 5. Similarly, what would be the 25th digit after the decimal point? So it would be 5, 5, every third position will be occupied with 5. So 24th place will be occupied by 5 and 25th place will be occupied again with 3. So by any ways you can actually find the nth digit after the decimal point. You can similarly find the 100th digit, you can similarly find the 125th digit, 1000th digit after the decimal point. Because of this reason, this number 8.325 bar belongs to the rational category. So now we do have a definition for finding the number to be a rational number and an irrational number, and the definition is nothing but if you are able to find any digit after the decimal point, then it belongs to the rational category. If not, then it belongs to the irrational category. Similarly, in the second example 6.333, we do have only 3 numbers after the decimal point. So this would be the first digit after the decimal point, second digit, third digit. So obviously you will be able to find any digit after the decimal point. So because of this reason, 6.333 also belongs to the rational category. Now the third example, 4.72561. Here the numbers are not repeating, but it is stopping at one particular point. That's the reason why you will be able to find the nth digit. You can find the 5th digit, 4th digit, 6th digit, or any number of digits that are given after the decimal point because it's stopping near one point. That's the reason this this number also belongs to rational category. So yes, let's get into the last example, 9.428638 ... which actually says that no numbers are repeating and it's not getting stopped at one point. So let me take that example, 9.428638 and it goes on without repeating until infinity. In this particular example, you will not be able to find the nth digit after the decimal point, because until 7 you know that this is the digit. First digit, second, third, fourth, fifth, sixth, 7, 8 and 9 digits. But after 9th digit, you will not be able to trace the digit after the decimal point. So because of that reason, this number belongs to irrational category.